Hello and welcome to this guide of how to graph conics. The conics that will be explored in this video will be parabolas, circles, ellipses, and hyperbolas. Let's take a look at the simplest of parabola equations, y equals x squared. Now I'm going to also show the vertex form of a parabola. It looks like this. In y equals x squared, the a equals 1, the k is 0, and the h is also 0. However, if we were to change the equation to y equals x squared plus 3, k now equals 3, which means that the y-coordinate of the vertex is no longer at the origin. It's now moved up to 3 on the y-axis. As for if we make that negative 3, then we drop below the origin and into the negative numbers on the y-axis. The vertex is now at 0, negative 3. Let's just leave the k at minus 3 right now. If we change the h, then we'll see that the parentheses will appear in the y equals x squared equation. If we want the x-coordinate of the vertex to be at 4, then we cannot have x plus 4 in the parentheses. The reason being that this is a negative sign, so it would end up looking like x minus 4. However, if we want the x-coordinate to be negative 4, then we can substitute a negative 4 in for h. But, as you can see, that's a double negative, which makes a positive. If we want to stretch the parabola, then we can change a. If we make a number more than 1, then we'll see that the parabola begins to stretch. However, if we make a less than 1, you'll notice that the parabola is compressed. Making a negative flips the parabola. Moving on to circles, in this equation, r represents the radius of the circle, which is the distance from the center of the circle to the outside. The radius will determine the size of the circle that you draw. Remember what I said about the parentheses in the parabola equation? How the negative sign can throw you off by switching positives and negatives a bit? Well, it's no different for this circle. So, in order to graph a circle here, what you gotta do is kinda do a bit the opposite of what the equation tells you to do. If it's x minus 3, let's say, then make that x-coordinate plus 3. And if it's y minus 5, that's a plus 5. Y plus 5 is minus 5. You can turn this into a bit of a game if you want. It's like a game kind of like Simon Says, except everything is not what Simon says. Everything is just someone saying, stand up, go 3 to the right, go up 3. Except instead of doing nothing, you do the opposite. So it's not really like Simon Says. Also, the center of a circle is h, k. So here's some examples of various values of h and k, and how it would affect where the circle is on the graph. So circles may have a scary looking equation, but when you know how to work with them, they're really not that bad. But now it's on to the ellipse. Before moving on to the ellipse, I'm going to show you a different version of the circle equation to help you better understand the ellipse equation. If we divide everything in the circle equation by the radius squared, then we get this crazy looking thing. And if we look at the ellipse equation, it's really quite similar. However, as opposed to having r squared, we have a squared, b squared. As opposed to having an equal radius that goes around the entire circle, and no matter what part of the circle you go to, it's the same length, in an ellipse, we can see that in some parts, this radius is longer than others. So that's why a and b are two different variables, because one is larger than the other. A is the, quote, radius on the x-axis, and b is the, quote, radius on the y-axis. If a was 3, then it would go this far, and if b was 5, it would be this tall, which as you can see, they are not equal lengths, so we are looking at an ellipse. Now you may be wondering, what happens if we take an ellipse equation and turn this plus sign in the middle into a negative sign? Well, I kid you not, the ellipse turns inside out. This is what you call a hyperbola. Now, in order to graph the hyperbola, we can take a and place the positive and negative variations, like, say that a squared is 4, that means a is 2, so we can put a point at 2 and negative 2. Now, if b is, say, 9, then it would be positive or negative 3. And we put those on the y-axis because it's in the y portion of the equation. Now, here's a little trick. What you can do is draw a box, like this, with these coordinates. And now take a straight edge and draw lines connecting the opposite corners. What we can do now is go from these x-coordinates and trace along these diagonal lines that we've just drawn. This is probably the most accurate way to sketch a hyperbola. Interesting thing that happens when you switch around the hyperbola equation. As you can see, this wouldn't do anything for a circle or ellipse, because it's a plus sign in the middle, so switching the order doesn't make any difference. But for a hyperbola, if you switch them, you end up with a totally different hyperbola. Now, as opposed to expanding outward, it now expands upwards and downwards. In other words, it opens in the y direction as opposed to the x direction. So, that was your little crash course on conics. Here's the little review. This is what a parabola equation looks like, vertex form to be specific. And this is a circle equation, a circle's equation, and this is an elliptical equation, elliptical, whatever, ellipse equation, let's just call it that, ellipse equation. And this is the equation of a hyperbola. Maybe I should just call it the equation of an ellipse. So, now you know how to graph these and identify the equations, write them and such. And hopefully that helps to make these equations look less scary and maybe a bit more fun. Just do the exact opposite of what they tell you to do in order to get the right answer. I hope you enjoyed the video and I will see you later. Goodbye!